Let us now try to understand the skewness and kurtosis. Okay, first we'll see what is skewness. Note that skewness, as per the dictionary definition, skewness means that you are not proper. Okay, that means the skewness, it measures a degree of symmetry in the dispersion of values, okay, around the mean. So it is a degree of symmetry around the mean, how the values are dispersed. We have seen that one of the measure of dispersion was a standard deviation. Okay, however, standard deviation will not give a correct data, okay, when the dispersion around the mean is not symmetrical. Okay, so symmetrical distribution, what you will find is, will have observation equally distributed around the mean. So as an example, suppose if you have mean is 2, okay, then one value is 3, one value is 4, and one value is 1 and another value is 0. So you see that this is the mean, okay, and the values are distributed symmetrically around the mean. So this will have skewness equal to 0. That means these are equally dispersed. However, in real life, what we see is that symmetrical distributions are not there. So symmetrical distributions are the one which have equal distribution and they will have skewness 0. But in real life, symmetrical distributions are not there. What we see is, we sometimes see that there is a long tail on one side, okay, and we'll see that, and the fatter distribution on the other side. So it is said as the skewness in the direction of long tail. Okay, so the long tail on one side can be both, can be right side of the mean. So if this is the mean, it can be on the right side or it can be on the left side. So note that the distribution will be fatter on the other side. So how it is being explained? So think about it. Let's say, suppose as of now, please note that we have not introduced diagrams like this. Okay, but this type of diagram is very simple to understand. Okay, what we have is, over here we have the values, okay, and on the y-axis we have the frequency. So on the x-axis you have the values, y-axis you have the frequency. Now think about when we are writing the values like 0, okay, and it has frequency here. Then you have 1, value 2, then minus 1, minus 2. Okay, if I draw it like this, it looks like that the values are symmetrical around 0. So this is your symmetrical distribution. Note that a symmetrical distribution, it means that the frequency of 1 and 2, frequency of minus 1 and minus 2 will be like equally distributed around this mean. So equally distributed will have skewness equal to 0. Okay. Now in real case, in practical scenario, what we have is, we do not see a symmetrical distribution. We can see a distributions like this. So what we are seeing is, you are seeing that there is a long tail. This is a long tail on the right side, and you see a fatter distribution. Here you see that the distribution is fatter as compared to this, right? So this type of distribution where the long tail is in the right, okay, this type of distribution, it is called as right skewed distribution. So this is your right skewed distribution, and for a right skewed distribution, the skewness, okay, will be positive. It will be more than 0. So this right skewed distribution are also called as positively skewed distribution. Okay, so there are two names that is given. These are right skewed, and these are also called as a positively skewed distribution, wherein the long tail is on the right, right, and the fatter tail is on the left, right. Now you can see a very like lots of example in the real life wherein you have this type of distribution. Think about the salary packages that people get in the engineering schools or MBA schools. Okay, you will find that there are few people, there are few students who get very large salary. So few students, they get very large salary, and there are lots of students who are getting the salary on an average, near the average or below the average. There are lots of students they are getting. Now because of these few students, let's say there are few students who are getting salaries like 10 lakhs, okay, right, and then lots of students are getting salary around 4 lakhs. Okay, what you will find is that the average salary will be very high. Okay, because of these few students, the average has become very high. right? And the distribution will look like something like this. There are few students who are getting high salary, the frequency is less. Okay, there are lots of students who are getting salary in the lower range, right? So because of these people who are getting very high salary, the mean gets dragged to the right side. So the mean is getting dragged to the right side. As a result, in a positively skewed distribution, what we see is that the mean would be somewhere around here. Okay, the median will be somewhere around here. Okay, note that this is the median. Median is the middle value, and this has the highest frequency. This is the mode, right? So in case of positively skewed distribution, what you find is that the mean is greater than the median, okay, which in turn is greater than the mode. So this is one of the properties of a positively skewed distribution. Okay, right? So your mean is greater than median, which in turn is greater than the mode. Okay, now I have been saying about the skewness being positive, negative, etc. Okay, it can be positive, negative, 0, but I have not given you the formula of the skewness. We don't have to worry about the formula of the skewness, but you need to know and understand one thing. Okay, understand one thing, that skewness is called as the third moment in statistics. Okay, note that mean is your first moment. Okay, your variance is called as the second moment, and skewness is third moment. Okay, and then when we see the kurtosis is called as the fourth moment. So note that the kurtosis is known as the fourth moment. But what are these moments? Moments means like to what degree of the deviation it is proportional to. So what we say is that kurtosis is proportional to x minus x bar whole to the power 3. So it is proportional to summation of x minus x bar whole to the power 3. Right? So this is 3, that is why it is called as the third moment. Okay, we don't have to worry about the formula, but yes, you need to know that it is proportional to x minus x bar whole to the power 3. That is what is kurtosis. So because you are taking a summation of x minus x bar whole to the power 3, it can be 0, it can be positive, it can be negative. Okay, whereas in case of variance, it was proportional to summation of x minus x bar whole square 2. That is why it was called as the second moment. So because it is 2, it can be 0 or positive, but it cannot be negative. Right? So kurtosis idea is that it's a third moment. Right? It can be 0, it can be negative, it can be positively skewed. Right? So we have seen the positive skewed distribution. Just a recap: positive skewed distribution, your mean will be greater than median, it will be greater than the mode. Okay, the positive skewed distribution are also called as right skewed distribution because the skewness or the long tail is seen in the right side. Okay, right? Then we also have, as we have seen, that the skewed can be negative. These are called as left skewed. Okay, or it is also called as the negatively skewed distribution. So in case of negatively skewed distribution, what you see is that the skewness is on the left side. The skewness that you find is on the left side. That is what is the characteristic. So what will happen is there are few values, okay, which are large negative values or which are very much lower than the mean. Okay, note that you will have over here mean. This is your mode. Okay, the highest frequency looks like that. This is the mode, highest frequency. This will be the median. So this is the mode, this will be the median, and the mean will be somewhere around here. Okay, the mean is getting dragged on the left side. Okay, because there are lots of values which are away from the mean and their weightage is dragging the mean to the left side. Right? So a negatively skewed distribution, the characteristics will be mean is less than the median, which is less than the mode. This is the characteristics of negatively skewed distribution. Now we have not seen the symmetrical distribution. We should have seen it earlier, but this is your symmetrical distribution. A symmetrical distribution characteristic is that your mean, your median, your mode are in the same place. So mean, median and mode are the same value. So as a result, the skewness of a symmetrically distributed is 0. It is not skewed. It is symmetrical to both the side of the mean, and your mean, median, mode are at the same point. So mean is equal to median, which is equal to the mode. So as you can see, this is your symmetric distribution, this is your negatively skewed distribution, and your positively skewed distribution. You need to know the relative points where these values are located. So what are the relative points where the mean is located, median is located? So you will be asked to identify. You will be asked to give that whether it is a third moment. Okay, you have to remember that whether it's a third moment. So and then you see that this is a long tail and this is a fatter tail. So in case of positively skewed distribution, the long tail is in the right side of the mean. In case of negatively skewed, the long tail is in the left side of the mean, and the fat tail is on the right side of the mean. So this is your skewness.